Okay, so we were doing work power energy, and I told you about the work energy theorem. Work energy theorem tells us that the summation of work done is equal to the change in kinetic energy. This is not only applicable for point particles, but it is also applicable for a system of point particles. Unlike F is equal to ma, which at this moment is only applicable for only point particles. And then we discussed a few questions. Uh, I hope you are getting the hang of it. And I told you that the concept of work energy theorem is just a tool. This means that the concept of work energy theorem is generally applied with other conditions. So I'm going to first give you a couple of questions where there is a condition and you have to decide that condition. And then I will formally lay down what conditions can you expect and how to resolve the problem if such conditions are given. Okay, having said that, I will be giving the resolution to a very small number of or relatively small number of problems. In most cases, you will have to decide what is the condition going to be. Now, the condition is generally going to involve drawing FPDs and writing down F is equal to ma. So the condition may be कि वहाँ पे एक particular force 0 हो गई है, या एक particular force maximum हो गई है, या एक particular force का component maximum हो गया है. Right? These may be certain conditions. There may be other conditions as well. There may be geometrical conditions, which we'll see. Okay, so we have so initially there are two blocks which are connected to each other by a spring, and they are kept on a frictionless, they are kept on a rough surface. The coefficient of friction is given as mu. We have to find the minimum value of force F such that the block of mass 5m just begins to move. Okay, remember the steps. Initial final configuration क्या होना चाहिए सिस्टम का, पहला. दूसरा, ये ट्रांजिशन इनिशियल टू फाइनल जब हुआ तो उसमें फोर्सेस क्या क्या एक्ट करें, एंड देन find out the work done on the system, and then find out the initial kinetic energy and the final kinetic energy, and then equate when you do, okay, when you do, it is my contention that when you apply summation f, summation work is equal to delta k, you are going to get two unknowns. Okay, it is my contention. It is my the problem laid out in front of you will be that after applying work energy theorem, you will get one equation and two unknowns. So to find that other unknown, you have to look at the problem again and think कि और क्या दिया हुआ है. सेम एक्सेलरेशन मतलब क्या हुआ? हाँ, ऑब्वियसली, यस यस, मैं समझा क्या बोल रहा. हाँ, बिल्कुल बिल्कुल सही. So this is the initial and this is the final. इसमें किसी को कोई शक, कोई डाउट, कोई आपत्ति, कोई प्रॉब्लम? Please look at the initial and final configuration of the system that I have made. Please answer then my question. In the final configuration, why has the 5M wala block not moved? In the final configuration, why has the 5M wala block not moved? In the final configuration, because the condition given, yes, because the words that I have used is that it is just about to move, just about to move, yes. So let's say that this distance is x, then summation of work will be work due to the spring and the work due to the friction. This will be half k 0 minus x square, okay, because the initial elongation was 0, initially is at its natural length, okay, plus the work done by friction will be, now friction on this block will be in this direction and its value will be mu n because it is moving, and n will be equal to mg, right? You have to be careful on all these accounts. Number one, what will be the magnitude of friction? Number two, what will be the direction of friction? Number three, what will be the value of n? So here then I will write down cosine 180 into mu n into x. Now why can I go back to the class 10th definition? What is so special? Why can I go back to the class 10th definition? Well, I can go back to the class 10th definition because the magnitude of friction always remains constant. The angle between the displacement and the direction of friction always remains constant. And the object is moving in a straight line. यहाँ पे एक चीज मैं भूल गया, क्या हो गया भाई, सबको याद दिलाना चाहिए ना. Work done by external agent plus. So what is work done by external agent? Well, work done by external agent should also fall back on the class 10 formula because the magnitude of force applied by the external agent is constant. The direction is constant. That means the angle between displacement and the direction of force will be constant. And the block is moving along a straight line. So I can simply write force into displacement into cos theta. I hope ये सबको समझ में आ रहा है. Anybody having any kind of doubt must ask. So this will be equal to minus half kx square minus mu mgx plus fx. Okay. Now initial kinetic energy of the system is equal to 0. Anybody willing to tell me what will be the final kinetic energy of the system? What will be the final kinetic energy of the system? What will be the final kinetic energy of the system? Very good, Shivan. Yes. What will be the final kinetic energy? Yes, Pratiksha. Good. The final kinetic energy of the system is bound to be 0 because जहाँ पे मैंने बोला कि मेरे को minimum F चाहिए, इसका मतलब कि मैं स्प्रिंग का मैक्सिमम इलोंगेशन चाहता हूँ, right? And the condition is that the block of mass 5m just moves just moves का मतलब acceleration 0, velocity 0. Okay, so we get final kinetic energy is equal to 0, right? Please take a screenshot. I'm going on to the next slide. Please take a screenshot, write it down. Please take a screenshot. So I will get now the equation, which is minus half kx square minus mu mgx plus fx is equal to 0. Right? So now x cancels out and I get f, which I wanted to find out, which is being asked in the question in the first place. F is equal to half kx plus mu mg. Right? Now remember that x is an unknown. And I told you that when you apply here the work energy theorem, right, you are going to get one equation and two unknowns, right? And here it is, one equation and two unknowns. F is an unknown and x is an unknown. So how can I find this? How can I find this? Unknown? Any idea? What should I do to find x? Read the question. हाँ क्या ये वर्क डन ऑन 5m तो 0 है ना? मैंने बताया था ना कि स्प्रिंग का हम नेटवर्क, हाँ फिर क्या करेंगे? प्रतीक्षा? हाँ पार्थ सही बोल रहा है. हाँ ये शौनक तो हाँ श्योर गुड यस शौनक आधा सही है आधा गलत. हाँ. So what is the condition here? Condition is that 5m just moves. This implies that force on 5m should be equal to the max value of friction on 5m. So 5m के ऊपर m लगा हुआ है, mg लगा हुआ है, स्प्रिंग फोर्स लगा हुआ है और फ्रिक्शन लगा हुआ है. So condition for 5m to just move surely must be that F spring should be equal to mu n should be equal to 5 mu mg. Right? And F spring is equal to kx. Sorry. Kx is equal to 5 mu mg. So x is equal to 5 mu mg. Okay. Let's place this here. So F minimum is equal to half into k into 5 mu mg by k plus mu mg, and this is equal to 7 by 2 mu mg. Now the moment I gave this question, somebody answered that this minimum force should be 6 mu mg. Right? And it looks like that, right? It looks like that because हमारे पास ये जो टोटल मास है ये 6m है, यहाँ भी म्यू है, यहाँ भी म्यू है, तो ये फोर्स का वैल्यू तो 6 mg होना चाहिए तभी दोनों मूव करेंगे. But that is not the case. Okay? That is not the case. I only require 7 by 2 mg. That means 3.5, a little over half of what is minimum according to the initial answer. Right? Why is it? अगर ये दोनों ब्लॉक स्ट्रिंग से कनेक्टेड होते तब क्या होता? Then definitely the answer would have been 6 mg, right? And we have done a question like this. यहाँ पे हमने force required to move two blocks connected by a string which were kept on a rough surface. We had worked it out, right? But what is happening here? ऐसा क्यों है that force is less than that, less than 6 mg? The answer is, of course, because of the spring. So now you can ask, what does the spring do? Well, I can answer this in two ways. I can answer this in two ways. Let me give you the answer in both the ways. The first way is a crude way of answering. Okay, it is not quantitative, it is qualitative. So the first way of answering why this F minimum is less than 6 μmg is that when I apply the force on the M mass wala block, when I apply the force on the first block, I am doing some work. Okay, I am doing some work. And this work is ultimately not changing the kinetic energy of the system. Okay, because finally kinetic energy तो zero हो गई. लेकिन मैंने तो यहाँ से यहाँ खींचा ना इसको, मैंने तो इस ऑब्जेक्ट को यहाँ से यहाँ खींचा, right? I have pulled this object from this point to this point. So I have definitely done some work. This guy has definitely done some work. Okay? And this work has gone into the system. And this work has been stored as the potential energy in the spring. Okay? This has been stored in the spring as potential energy. And the work that I have done has expanded the spring to such an extent that the spring force has become equal to 5 μmg. The spring force is sufficient to pull the second block. Okay? So the crude answer is that I have done work, and this work has been stored in the spring as potential energy, and now this potential energy is sufficient to move the 5m wala block. A more accurate answer, a more quantitative answer would be where I invoke what I discussed in the last class. If you remember, मैंने spring mass के बारे में बताया था, और यही चीज मैंने आपको बोली थी मैं बार बार बताऊंगा, तो वो यहाँ पे भी मैं बताऊंगा. And this is what you have to really understand. So when I apply a force, which is 3 by 2 μmg, right? 5 by 2, sorry, 7 by 2, 3.5 μmg. Then this force is definitely greater than the friction force on this block, right? The friction force on this block can have a maximum value of only μmg, and I have applied a force 3.5 μmg. At this stage, since the spring is at its natural length, the spring offers no force. So as far as the block of mass m is concerned, इसके ऊपर केवल दो forces लगी हुई है, एक ये force F और दूसरा friction. And because this F is much greater than maximum value of friction, the block begins to accelerate towards the right, and therefore it begins to develop a velocity towards the right, and therefore it has a displacement towards the right. The moment the block undergoes a displacement, the spring gets stretched, spring gets elongated, and it starts to apply a backward force on the block. Right? But since this elongation is extremely tiny, this force plays a dominant role, and the net acceleration of the block is towards the right, and therefore the velocity of the block towards the right now increases. Remember that the velocity has already changed from 0 to some value, and now since the net force is to the right, the velocity increases, and therefore the object has a displacement towards right, more displacement towards right. Therefore the spring will elongate further and it will apply a greater force on the block. However, this greater force is still insufficient with friction to match this external force F, and therefore the net acceleration is still towards the right, although now it is lower in magnitude, but the acceleration is towards the right, its direction is towards the right. Therefore, velocity of the object of mass m towards the right will still increase. Okay, and this will keep on happening until the elongation of the spring becomes such that the spring force combined with the friction force on the block will match the external force. And when that happens, the net force on the object becomes zero. But only the net force has become zero. The velocity of the object by this time has developed to a large value, and this velocity is towards the right. So the moment the object goes further to the right, now kx becomes larger, and the value of the force kx plus the friction acting in the backward direction on the block of mass m, they now exceed the value of F. Therefore, the net force on the block is towards the left, although the velocity of the block is towards the right. So the acceleration now of the block is very small, but it is towards the left. Therefore, the velocity of the block will now decrease. Okay? The velocity will decrease. Okay? Please don't confuse it with वो पलट जाएगा. उसकी वेलोसिटी कम हो रही है, लेकिन उसका डिस्प्लेसमेंट अभी भी राइट साइड में ही हो रहा है. इसका मतलब कि ये स्प्रिंग फोर्स और ज्यादा बढ़ रही है. तो जब स्प्रिंग फोर्स और ज्यादा बढ़ रही है, तो अगेन स्प्रिंग फोर्स कंबाइंड विद द फ्रिक्शन is now exceeding capital F, right? So the net acceleration now is towards the left, but the velocity is towards the right. Therefore, the velocity will decrease. Although the velocity is decreasing, its direction is towards the right. Therefore, displacement of the block will be towards the right, and the spring will further get elongated. Or elongation होएगा spring, or spring force बढ़ जाएगी. And there will come a point of time when the block finally comes to rest. मैं तो फोर्स लगाया हुआ है, ये एफ तो मैंने कभी छोड़ा ही नहीं, लेकिन अब आके ये ब्लॉक रुक गया. मैंने फोर्स लगाया हुआ है, लेकिन तब भी ये ब्लॉक आके रुक गया. जब ये ब्लॉक रुक गया, the block has stopped, right? Then the elongation of the spring is maximum. And the maximum elongation of the spring, of course, results in a spring force. And this spring force is equal to 5 mu mg. Therefore, just beyond this, यहाँ पे हमारा कैलकुलेशन खत्म हो गया, यहाँ हमने सब कुछ वर्कआउट कर लिया. Just beyond this, इस फोर्स, ये जो मैंने फोर्स लगाई है, वैल्यू निकाली है 3.5 mu mg, इससे जस्ट ऊपर मैं फोर्स लगाऊंगा, and that's it. 5m wala block will begin to move. The motion of the two blocks will be extremely complicated, right? Which we are not going to discuss. We are in fact not in a position to discuss कि कैसा motion होएगा. We will discuss someday कैसा motion होएगा, but still हम उसको qualitative ही करेंगे, quantitative नहीं करेंगे. Quantitative SHM chapter जब पढ़ेंगे तब then we can have a quantitative discussion on the motion of the two blocks. Okay, आया समझ में? I hope कुछ next question में दूँ. kx बड़ा हो जाएगा तो नेट फोर्स पीछे हो जाएगी. When kx is greater, when kx plus the friction force combined is greater than capital F, net force is backwards. Chalo, so next question, try this out yourself. So spring has natural system is released for rest. High velocity of flux when when the upper block leaves horizontal surface. Okay, so hidden within the question is one application of work energy theorem and one extra condition is given. हाँ, स्प्रिंग का एंगल कॉन्स्टेंटली चेंज होता है. हाँ, तो बड़ा आंसर है। हाँ भाई, सब लोग शांति, बड़ा अच्छा लगता है मुझे, शांति रहती है तो। देखो, फाइनल कॉन्फ़िगरेशन, ये बनाया सबने, फाइनल कॉन्फ़िगरेशन बनाया सबने, गुड, ठीक है। नाउ वन मोर art or one more talent that you must learn, one more art, one more talent that you must learn is the art of minimizing the unknowns. Okay? Art of minimizing the unknowns, or at least making the unknowns, choosing the unknowns in such a way, that the maths becomes easy. Now this only can come through practice. ये मैं आपको सिखा नहीं सकता हूँ, ये कोई आपको सिखा नहीं सकता. This can only come through practice. So here, of course, our instinct tells us that we should choose. I hope आपके instinct ने आपको बोला that we should choose this quantity as h. If this is a quantity h, then this is also a quantity h, right? And we can express everything in terms of h. But it turns out that it is easier to handle this problem if instead of saying that this is h, I say that this is theta. And if this is theta, then this quantity, right, will be equal to L tan theta. This quantity will be equal to L sec theta, and this distance again will be equal to L tan theta. Okay? अभी तक आ रहा है समझ में? Summation of work done on the system will be equal to work done by the spring on the first block plus work done by the earth on the second block plus work done by tension and work done by normal reaction. I don't like to write this because we know that this is going to be zero. Work is being done by the spring on the upper block. Work is being done by the earth on the lower block, and normal reaction and tension have no role to play. In fact, this is why we go into work energy, because we don't want to get involved with constraint forces. So what is the work done by the spring? Well, the work done by the spring is half K initial elongation or compression square, which is 0, because the spring has a natural length L, and since this length is L, therefore it is at its natural length. Minus, okay, now here you have to be slightly more careful. You can't write L sec theta whole square, because L sec theta is the length of the spring. It is not the elongation of the spring. So it must be L sec theta minus L whole square. This is the elongation of the spring. L sec theta is the length of the spring at this location, and minus its natural length will give you the elongation. Okay? कहीं पे भी नहीं समझ में आएगा, प्लीज रेज योर हैंड एंड आस्क. Plus work done by the earth on the second block, this is easy, it is equal to mgl tan theta. Now the initial kinetic energy must be the initial kinetic energy of block 1 plus the initial kinetic energy of block 2. The final kinetic energy must be equal to the final kinetic energy of block 1 plus the final kinetic energy of block 2, which will be equal to half mv square plus half mv square, because after they have come to this position, right, their velocity must be something, but I know that the velocities must have the same magnitudes because they are connected to each other by a string. ये velocity की value क्या रहेगी ये मेरे को नहीं मालूम. So what is the equation that I get? Equation that I get is minus half kl square sec theta minus 1 whole square plus mgl tan theta, yeah, is equal to final kinetic energy mv square minus, right? And as I told you, this condition, this condition is when is the work energy theorem, and it has two unknowns. Theta is unknown, v is unknown. I don't know either. क्या निकालना है मेरे को भाई, ये देख लिया जाए. Find velocity of the blocks, ये मेरे को निकालना है. इसका मतलब ये हुआ that I want to find this and I want to get rid of this. I don't want theta in my answer. Theta is an unknown. Now I ask you, what is the condition given? Just leaves the surface. That is the condition. Just leaves the surface. That is the condition. क्या लीव कर रहा है, क्या इसका मतलब क्या हुआ? इसका मतलब क्या हुआ? अगर ये ऑब्जेक्ट, बहुत बढ़िया शिवेन, यस, अगर ये ऑब्जेक्ट ये हॉरिजॉन्टल सरफेस को लीव कर दे रहा है, let me just draw the video of this object. So we have mg acting here, we have tension T acting here, we have a kx acting here. I'm writing kx, it is not x, it is L sec theta minus L. We have a kx acting here, and we have, very good, yes, and we have a normal reaction acting. What should it mean that it leaves the surface? Leaves the surface in physics always and always has only a single meaning, and that is, like you are saying exactly, normal reaction is zero. Okay? So leaves the surface, which is the key statement here, leaves the surface, right? Leaves the surface implies that normal reaction is equal to zero, which in turn implies if this angle is theta, kx cosine theta must be equal to mg. Right? But x क्या चीज है? Let's be kl sec theta minus 1 into cos theta is equal to mg. और अगर ये cos थीटा को मैं ब्रैकेट के अंदर डाल दूंगा तो आई विल बी लेफ्ट विथ kl 1 minus cos theta is equal to mg. Yes, आ रहा है सबको समझ में? So cos theta, right, cos theta must be equal to 1 minus mg by kl. And if you know cos theta, then obviously you can work out tan theta. I don't think that should be a problem. and obviously then you can work out sec theta. That should not be a problem. है ना? So let me write it this way. Let me write it this way. V is equal to under root of GL tan theta, which I will write as under root of sec square theta plus 1. उल्टा लिखा मैंने कि गलत? सही लिखा, गलत लिखा है. -1 होता है, +1 होता है tan theta. माइनस या प्लस? माइनस KL square by M into sec theta minus 1 whole square. And then you get the lengthy answer of
KL square by 2m होगा ना.
KL square by 2. Sec theta, the value आप डाल दो and you get the answer. Okay. I could have chosen H, लेकिन अगर मैं H चूज करता तो थीटा फिर आ जाता वहां, क्योंकि मेरे को kx cos theta तो लिखना ही पड़ता, right? So that would have made a mess. This is also made a mess, but इसका mess थोड़ा handleable है. हाँ वही x है, वही मैं बोल रहा हूँ ना, उसका mess. If you take x या h, तो उसका जो बैंगन का भरता बनेगा, हालत खराब हो जाएगी. Like I said, this is an art where you actually in your mind predict which variable will give you less number of equations. It's like playing chess. You have to think 2 moves ahead. क्या होने वाला? नहीं बच्चा, मेरा फाइनल आंसर थोड़ी ना मैंने लिखा है. देखो ना, मैंने तो फाइनल आंसर लिखा ही नहीं है. मैंने आपको बोला कि ये v का वैल्यू मैं यहाँ पे लिख रहा हूँ और ये cos थीटा की वैल्यू मैं यहाँ पे लिख रहा हूँ. तो ये cos थीटा की वैल्यू जब मैं यहाँ और यहाँ सब्स्टिट्यूट कर दूंगा, that will give me the final answer. The final answer will not be that complicated because अगर आप देखो तो ये काफी चीजें इसमें कैंसिल होने जा रही हैं. Many things will get cancelled out. ये HC वर्मा का क्वेश्चन है. You can see the solution. You can see the answer to this. I think this is question number 42 or something. I don't remember. Work energy. Okay, chalo. So now let me tell you about some conditions which will come in front of us. Please take a screenshot of this before I move. Please take a screenshot or write it down. चल आगे बढ़ते हैं. So what are the various conditions you will see? Conditions and their resolution. First condition is completes a circle. Right? And I'm talking about a vertical circle. So this is the condition. What do I mean by condition? Well, this is what will be given in the problem. Same words may be used, different words may be used. But the meaning is always same. We have an object which is connected to a string, or maybe it is going to go in a circular track, whatever, does not matter. But this object has a condition that it must complete a vertical circle. This is what should be the minimum velocity so that this happens, so that it completes a vertical circle. What should be the minimum height from which it is released so that it completes a vertical circle? The words may be different, but the meaning will always be the same. Condition is vertical circle complete hona hai. So in this case, we have a simple resolution. And this simple resolution is something that you would not expect, because well, you will understand, of course, but I hope that you will be able to understand the fact that to complete a circle, पहले आप बताओ, आप first let me get your perspective. What do you think the condition should be to complete a circle? What do you think? eh, What do you think the condition should be so that the object completes the circle? स्लिपिंग की तो बात ही नहीं हो रही है, फ्रिक्शन आएगा कि नहीं आएगा. Vf equal to Vi नहीं, मिनिमम स्पीड और वेलोसिटी नहीं. हाँ, ये प्रतीक्षा ने सही बोला, पार्थ ने बिल्कुल सही बोला है. आ कहाँ से रहा है पार्थ, ये तो बताना मेरे को. So resolution is that at the topmost point, at the topmost point, very good Anish, yes. At the topmost point, its velocity must have minimum magnitude for circular motion. Right? What does this mean? Now, if any of you are getting this picture in your mind, नहीं, वर्टिकल सर्कल कंप्लीट करने के लिए तो टॉप मोस्ट पॉइंट पे वेलोसिटी 0 हो जानी चाहिए, तो ये पिक्चर बिल्कुल गलत है. अगर आप रोलर कोस्टर में जा रहे हैं, आई होप दैट ऑल ऑफ यू हैव बीन टू iMagica. अगर आप रोलर कोस्टर में जा रहे हैं और रोलर कोस्टर उल्टा लूप द लूप में जा रहा है, सर्कल में जा रहा है, वर्टिकल सर्कल में जा रहा है, और टॉप मोस्ट पॉइंट पे वेलोसिटी रोलर कोस्टर की 0 हो गई। तो आई होप दैट यू रियलाइज दैट आप वहां पे अटक जाओगे, फंस जाओगे। अगर मैंने रस्सी पे पत्थर बांधा हुआ है, अगर मैंने रस्सी पे पत्थर बांधा हुआ है और मैं रस्सी को गोल गोल घुमा रहा हूं, and at the topmost point the velocity becomes 0, then the stone will not complete a circle but it will simply fall down. So at the topmost point, good, at the topmost point of this vertical circle, you should draw the tangential axis, the radial axis. Since this is a vertical circle, mg is acting in the downward direction, and there will be some tension or normal reaction at the top. The normal reaction would be due to a circular track. If it is there, tension would be there due to a string. And therefore, the equation for the circular motion that you would write down, if the speed at the topmost point is v, then the equation that we will write down will be that t or n plus mg is equal to mv square by r. The right hand term is very important because mv square by r tells me that there is circular motion. So v is equal to root of r into t or n, whatever, plus mg divided by m. Now, for v to be minimum, t or n should be equal to 0. This means that the minimum velocity at the topmost point is equal to root rg. This is what you have to remember. So I'll put a star mark here. ये आपको याद रखना है। अगर ये सेंटेंस या इसके सेम मीनिंग का सेंटेंस क्वेश्चन में आ गया तो हमारे लिए इसका रेजोल्यूशन है दैट टॉप मोस्ट पॉइंट ऑफ द सर्कल, द वेलोसिटी मस्ट बी रूट the radius of the circle multiplied by g. So this will be applied in conjunction with the work energy theorem to get the answer of whatever question is being asked. Please write this down, take a screenshot. Vf is equal to Vi is not a valid condition, right? I mean that may be that may be for not only circular tracks, for any track it would be Vf is equal to Vi. Because gravity, if only gravity is doing work, right, then the net work done by gravity would be zero and net change in kinetic energy would be zero. Okay, so I'm going on to the next slide. So let's start off with a very, very easy question. Find minimum V naught for completion of something. हाँ, नहीं गलत है सोना. गलत है सोना, बार बार लिखेगा सही थोड़ी ना हो जाएगा. हाँ नीच बिल्कुल सही. हाँ प्रतीक्षा बिल्कुल सही. Good. So I will take this as the initial position and I will take this as the final position. Right? Remember, बाकी किसी चीज में कोई चेंज नहीं आया. वर्क एनर्जी थ्योरम एज इट इज अप्लाई होएगा. So summation work will be work done by earth, and I really don't want to write it. Work done by normal reaction, which will be zero anyway. So work done by earth will be minus mg into 2r. क्योंकि ये यहाँ से यहाँ जो ऊपर गया है ये डिस्टेंस 2r. And initial kinetic energy is equal to half mv naught square. Final kinetic energy is equal to half mv square. I don't know either. So minus mg into 2r work done is equal to final kinetic energy minus initial kinetic energy. M cancel हो गया. V naught square is equal to V square plus 4gr. Right? मैंने बस rearrange कर दिया है. And we know that for completion of circle, velocity at top must be equal to root rg. So V naught square is equal to rg plus 4rg. V naught is equal to root of 5rg. सही तो बोला था शिवेंद्र ने. So what you can do now, yeah, I'll change the slide for a moment. What you can do now is you can say that either this is the condition for completion of a circle, or you can say that V at the bottom of the circle must be equal to root 5 arch. You can say that as well. ठीक है? Okay, now I want to give you another question. Please take a screenshot. Please take a screenshot. Please take a screenshot. यहीं पे फ्रिक्शन नहीं है, ओके, ऑल फ्रिक्शनलेस. बिल्कुल सही. नहीं चैतल, नहीं गलत. हाँ प्रतीक्षा. यस. यस शिवन. Yeah, so you can either take the topmost point or the bottommost point as the final point, because the initial point is given to us, right? Initial point is given to us. And I will take this as the final point. Make खुशी गलत answer. So summation of work is work done by Earth and nothing else, plus mgh. Initial kinetic energy is 0. Final kinetic energy half mv square, where v is equal to root of 5gr. So final kinetic energy half m 5gr. हाँ तो लिखा बिल्कुल सही. Yes. So mgh is equal to 5 mgr by 2 H is equal to 5R. Okay, so this is actually how they design roller coasters. The height of the roller coaster from where your cart is coming down for a loop the loop must be greater than 2.5 of the radius, otherwise लोचा हो जाएगा, सर्कल ही नहीं कंप्लीट होएगा. चलो एक कदम आगे चल रहे हैं, एक कदम आगे चल रहे हैं. Imagine that this is a roller coaster. Imagine that this is a roller coaster. Okay, and let's have some fun with this roller coaster. So what I do is that I remove this track. So second part. Now the green portion is removed. Okay, let this be point A, let this be point B. Find H so that block completes. आया क्वेश्चन समझ में? अभी क्या किया मैंने, ये एक रोलर कोस्टर है और ये रोलर कोस्टर के टॉप पार्ट ऑफ द ट्रैक को मैंने वहां से रिमूव कर दिया. And I still want the roller coaster to complete the circle. That means I want it to go from point A to point B. But this time, when the roller coaster goes from point A to point B, how will it go? कैसे जाएगा? ट्रैक तो है नहीं, कैसे जाएगा? Exactly. Shiven has given the correct answer. It will fly. हाँ, उड़ के जाएगा. बिल्कुल सही बोला, उड़ के जाएगा. Can you find H? Can you find H for this absolutely dangerous roller coaster? ना भैया तरुण, तूने सबको मार डाला. H will not be the same. ना. हाँ नहीं, it's not complete the circle. It cannot now, of course, it cannot complete the circle. But what the question means is that नहीं 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 नहीं. What the question means is, तभी मैंने पूछा था ना कैसे जाएगा वहां से. What the question means is that now instead of following this circular track, it will be going like this. मेरा डायग्राम बड़ा खराब बना है, बट ये है क्या? I'll try it again. Yes, exactly. Yes. नहीं बन पा रहा है. हाँ, मतलब ये प्रोजेक्टाइल हो जाएगा. बहुत बढ़िया पार्ट दिया इसका. Yes, yes, that is the correct answer. तो रोलर कोस्टर प्रोजेक्टाइल बन जाएगा. नहीं नहीं खुशी, मेरे को एच की वैल्यू चाहिए भाई. हाँ शिवेंद्र, सही है. Okay, so the thing is that we are dealing with a projectile at this point, and the projectile will move with a velocity v, which should be tangential to the track. Right? So this is tangential to the track at point A. And then this object will, if I can draw, this object will go into projectile motion, and it should land exactly at point B. Right? It should land exactly at point B. That means that this distance must be what? This distance must be what? ये वाली जो मैंने अभी डिस्टेंस बनाई, ये क्या होना चाहिए? हाँ, इसकी वैल्यू बता रहे हैं ना आप प्रतीक्षा, लेकिन है क्या चीज? प्रोजेक्टाइल के लिए क्या? हाँ, yes, this will be the range of the projectile. हाँ, and in this triangle, its value will be, like Pratiksha has correctly said, 2r sin theta. So we are looking for a projectile which has a range of 2r sin theta, but I do not know, at least at this point, I do not know the angle of projection. Or do I know the angle of projection? Well, if it is tangential to the point A, then this angle must be theta, and this angle must be 90. So this angle must be theta. Right? So we have a projectile which has been launched with an unknown velocity v and a known angle theta, such that its range is 2r sin theta. So range of a projectile is given by v square into sine 2 theta by g. सही याद है मुझे? ये गलत है. This is equal to 2r sin theta. So v square must be equal to gr अपॉन cos। आया समझ में क्या हुआ? मैंने साइन थीटा को 2 साइन थीटा cos थीटा रख दिया और राइट हैंड साइड में 2 साइन थीटा है तो वो उससे कैंसिल हो गया और cos थीटा फिर नीचे डिनोमिनेटर में आ जाएगा, कैंसिल हो जाएगा, साइन थीटा कैंसिल हो जाएगा। So this means that at this point A, okay, and let me just draw the horizontal level of A. At this point A, the velocity must be root gr cos theta. So I choose this as the final point, I choose this as the initial point, and I write summation of work is equal to work done by Earth, nothing else, must be equal to plus mg into this distance. What is this distance? Well, ये पूरा डिस्टेंस तो h है और यहां से लेके यहां तक r है, यहां से लेके यहां तक r कोसाइन थीटा है। आई होप एवरीबडी इज फॉलोइंग मी। यहां से यहां r डिस्टेंस है, रेडियस है ये तो, और ये डिस्टेंस r कोसाइन थीटा है बिकॉज दिस इज रेडियस r, this is angle theta, so this must be r cosine theta, right? So this distance will be equal to h minus r 1 plus cosine theta. So mgh minus r 1 plus cosine theta is work done by the earth. Initial kinetic energy is 0. Final kinetic energy is half mv square, which is mgr by 2 cos theta. Right. So I will just equate mg h minus r into 1 plus cosine theta must be equal to final kinetic energy mgr upon 2 cosine theta. mg cancel out, h is equal to r1 plus cosine theta plus 1 upon 2 cosine theta. ये फैक्टर मैं निकाला था मेरे ख्याल से बात। This must be the height. So you see what I've done and what I will keep on doing and what you will keep on facing. पुराने टॉपिक्स फिर इसमें घुस के आ जाएंगे। इसमें जो वर्क एनर्जी थ्योरम है वो तो बहुत ही कम लगान, वर्क एनर्जी थ्योरम definitely will be the easiest part of the question. Right, so we will be revisiting everything again that we have learned. पुराने टॉपिक फिर से घुसते रहेंगे and this is what will keep on happening in physics now. आया सबको समझ में? Anybody not understanding? सबको आ गया समझ में? So I will give you a question, another question now. Please take a screenshot. And we will discuss this question in the next class. Okay, so you have lots of time to do this question. So a particle of mass m, I don't think we need mass m, but still ठीक है, दे दिया आपने। is suspended by a vertical string of length L. If it is given a horizontal velocity root 4gr, find its maximum height. For GL actually, because radius. Okay, we'll discuss this question in the next class. Please take a screenshot of this. नहीं भाई आर नहीं है, कॉम्प्लिकेटेड आंसर है, थोड़ा सोचना पड़ेगा इसमें क्या हो रहा है. यू हैव टू थिंक. इट इज नॉट स्ट्रेट फॉरवर्ड क्वेश्चन. अगर यही रूट 5GL मैंने लिख दिया होता तो इट वुड बी अ स्ट्रेट फॉरवर्ड क्वेश्चन. It is not a straightforward question. You have to do a lot of thinking. It is very similar to the last question, but it is not a very straightforward question. ठीक है, चलो फिर आई विल. ऐसा कुछ क्वेश्चन उसमें आ गया था क्या पार्ट टेस्ट में, मेरे को अभी किसी ने भेजा था. अगर ऐसा क्वेश्चन आया है वर्टिकल सर्कल वाला, दैट विल गो एज बोनस. दैट विल नॉट बी टेस्टेड ऑन दैट. चलो हाँ, तो उसको मैं बोनस करवा दूंगा. I'll see you guys in the next class, okay?